Hi everyone. My name is Karina White and I'm a PhD student at Rutgers University. And what I study is tissue engineering for the retina in the eye. So tissue engineering has kind of been a popular term thrown around there. So hopefully I can explain a little bit about what that is, as well as why I do it for the eye, what disease I'm looking at trying to treat with tissue engineering. So if you think about your whole experience as a human, if you're born with vision, that becomes like a very crucial thing, part of your human experience. You probably have hobbies and a job, and you think of a lot of experiences by what you see. You define your experiences by what you see, and you combine all your senses to remember, like provide memories. So it's really, really important. Now, that's different for people who aren't born with vision. They have a very different human experience. The people who aren't born with vision, if they lose their vision, later in life, that could be very traumatic. Um, they have to learn a whole new way of life. And this can be very hard for people who are maybe of a more advanced age, in their 50s, 60s, 70s. And that's what happens with a disease called age-related macular degeneration, which maybe you've heard of. Um, the onset is after 50, usually around 60. And what happens is you lose your central vision. So anything in front of you, you won't be able to see. Things to the side in your periphery, you might have okay vision depending on exactly how advanced your disease gets. So what we want to do is we want to prevent degeneration as people are getting older. And so the thing with age-related macular degeneration is there's no precise pathology of the disease known. So what I mean by that is it's not, well, first this happens, then this happens, and then this happens, and then your retina degenerates. We don't know what the cascade of events is. We do know a few things that happen before the retina degenerates. They happen in both healthy and diseased individuals, though they're seen to a further extent in diseased individuals, so we might be able to correlate that to the disease. But one thing that we do know that happens in the retina is your blood retinal barrier is affected before and during age-related macular degeneration. So the blood retinal barrier, it's a lot like the blood-brain barrier. It limits transport into and out of the retina, and it provides support through physical support, as well as giving proteins and things like that to the retina in order for the retinal cells to survive. So the blood retinal barrier is composed of two components. The Bruch's membrane is like an acellular membrane, so no cells. It's kind of like a collagen, stretchy, flexible membrane, and it's very thin. So there you have that, and then you have a thin layer of cells that sits right on top of that. That's just one layer thick. So it's one cell thick sitting on top of this membrane. And those two structures together provide support, and they limit transport into and out of the retina. So bad things can't come in, but waste comes out, good things come in. It protects the retina. It's very important. So what we look at is in age-related macular degeneration, that blood retinal barrier becomes dysfunctional. And this will happen, and your photoreceptor cells, which are really important in your vision, will start to die. So we want to prevent the photoreceptor cells from dying, and we want to reestablish a healthy blood retinal barrier. So in order to do this, what we look at is implanting a little construct that we can make in the lab that consists of a membrane, just like the Bruch's membrane, but it would be made out of a polymer. and the retinal pigment epithelial cells grown on top of that. So we're really just taking the native design of the membrane and cells on top of it that you see in your retina. We're trying to create that in the lab so that we can then implant it if your blood retinal barrier becomes dysfunctional. So that will hopefully prevent a very bad far degeneration of your photoreceptors, and then you'll be able to retain some vision. So that is the work that I do. I look at how we can design the scaffold and cells construct in the lab that will then be a successful implant. So we don't want the implant to be rejected. We don't want it to have mismatched properties to the eye. You don't want something that doesn't fit into the native environment you're putting it into. So yes, I look at the design parameters of the scaffold to make sure the cells are functioning correctly on it, that they're really going to do their job once they get into the eye, to really prevent this degeneration that a lot of people see as they get older. So with that, I'll end. And if anybody has questions about my research or the tissue engineering field of trying to implant a scaffold with cells into various portions of your body to help regenerate or reestablish function, I'd be happy to take them at this time. Thank you so much for listening.